So here we want to know, we want to calculate, we have the density of Jupiter is 1.33 grams per centimeters cubed. What's the density in pounds per foot cube? So here we have to convert both the top unit and the bottom unit. So we have grams per centimeter cubed, and we want to go to pounds per foot cube. So we want to convert both the top and the bottom. It's given us the conversion factor of 2.2 pounds in 1 kilogram. Anything else it didn't give us, so we can use whatever we want. And just for the interest of significant figures, I'm going to use 1 inch equals 2.54 centimeters. That's how I'm going to get from metric to English. Now, in addition to this, we want feet cubed, so we're going to need a conversion factor with feet. And so what we know is, we know that there are 12 inches in 1 foot. Because we want to go from grams to pounds, it gives us pounds to kilograms conversion. And we want to go from centimeters cubed to feet cubed, and we want to use, to go from metric to English, we want to use inch to centimeter. So we need to somehow get to inches first before we can get, or excuse me, from centimeters we can get to inches, but then we need to get to feet. Now you'll notice here that I've put the conversion factors for the normal unit, centimeter. But you'll notice here that this is centimeter cubed and this is foot cubed. So to get to conversion factors of the cubed units, we have to cube these conversion factors. Regardless of what conversion factor you use, unless, you always have to cube if they're not the cubed conversion factors. So when we cube it, we'll get how many centimeters cubed in an inch cubed and how many inches cubed in a foot cubed. So we get 16.387 centimeters. And again, since 2.54 was exact, this is still exact, 16.387. Now we're going to do inches, so you do 12 cubed. And if you don't have the cube function on your calculator, what you can do is just multiply 12 3 times. That'll be the same thing. So here now you see we have the conversion between centimeters cubed and inches cubed to feet cubed. So that's how we're going to go from centimeters cubed to feet cubed. Now with the pounds and grams, we need one more conversion factor, which is how many grams in a kilogram. So now we're ready to convert. So what we're going to do is, and I like to do this in 2 steps. You can do it, again, there's multiple ways to do this. If you do it a different way and get the same answer, no worries. So in the first step, we're going to take grams, convert it to kilograms, and convert that to pounds. And we're not going to touch the bottom unit, centimeters cubed. So centimeters cubes remains the same in the first step. In the second step, we're going to take centimeters cubed, convert it to inches cubed, convert it to feet cubed. So this is the denominator that we'll be working with. So first we're going to convert the numerator, the grams, to pounds. The second step, we're going to convert the denominator from centimeters cubed to feet cubed. So we're going to do it in 2 steps. Again, there's multiple ways you can do this. So I'm going to draw my train track. So now notice when I write it now, it's 1.33 grams, and I'm going to put centimeter cubed on the bottom. But we're not going to mess with centimeter cubed. So the first step, we want to go from grams to kilograms. So in the next empty train track, we're going to put grams on the bottom and kilogram on top. Because now we can convert it grams to kilogram. The next train track, we're going to go from kilograms to pounds. So in our conversion factor, we're going to put the kilogram portion on the bottom and the pound portion on top. Now, when you do this multiplication, again, keep quite a few significant figures. I'd keep maybe 4 or 5. That way, we're only going to round at the end. So now you multiply what's on top, you divide by what's on the bottom. And so here we get, this is all the digits that the calculator gave me on this one. So it's, and here the units are pounds per centimeter cubed. So now we're going to take this, and in the next step, we're going to convert the denominator units. We're going to go from centimeters cubed to foot cubed. Now pay attention here, because since it's in the denominator, we're going to do kind of it backwards. So you notice when we have grams on top, in our conversion factor, grams goes on the bottom, kilogram goes on top. But since we're going to be working with the centimeter cubed, which is on the bottom, we're going to be doing the opposite. So whatever's on the bottom in the conversion factor is going to go on top, and the other one goes on the bottom. Draw my train tracks. So we're going to have pounds on top, centimeter cubed on the bottom. So our first step is we want to convert centimeter cubed to inches cubed. So in the next train track, in our conversion factor, since centimeter cubed is on the bottom, in our conversion factor, centimeter cubed is going to go on top. Again, we're converting the denominator. And that means inch cubed goes on the bottom. The next step, we want to take inch cubed and convert it to foot cubed. So in our conversion factor of inch cubed to feet cubed, the inch cubed portion goes on top, and the feet cubed goes on the bottom. And you'll notice that everything cancels but feet cubed on the bottom. So now we have pounds per foot cubed. So again, you multiply everything on top, you divide by what's on the bottom. And luckily on the bottom is all ones. So the calculator gives me this. And now we need to do significant figures. So our original number had 3 significant figures. Our conversion factor of pounds to kilogram, that's English to metric, this has 2. Now kilogram to gram, that's exact. Inch to centimeter is exact, and inch to foot is exact. So here the fewest significant figures is 2, so 1, 2. So our answer should have 2 significant figures, so it would be 83 pounds per foot cube. So here we have Dash has a top speed of 250 feet per second. How long in hours will it take Dash to run from San Antonio to Chicago? And San Antonio to Chicago is 1,997 kilometers. And it gives us 1 mile is 1.609 kilometers. So we want to know how long in hours. So we want to know time. So what we're looking for is time in hours. It'll take Dash to run from San Antonio to Chicago. And so what we're given is we're given the speed in feet per second. And somehow from there we need to get hours. And we're given distance. So we have speed and distance. And we need to find hours it'll take. And so again, there's multiple ways you can do this. I'm going to show you one route, but if you have a different route and it works, no problem. So what I'm going to do is I'm going to start on call distance D. And we know the distance is in kilometers. I'll use lowercase d. So that's what we know is given to us in the problem. We know that from San Antonio to Chicago, it's 1,997 kilometers. But we have speed in feet per second. And if you remember, time is distance divided by speed. So if we know how far you're going to travel and we know the speed, if we take the distance divided by the speed, it'll give us the time. And since our speed is in feet per second, this will give us the time per second. So the way you can interpret this 250 feet per second is that you can write it as a conversion factor that 250 feet equals 1 second. This is given to us in the problem. So if we know the distance in kilometers, we need to get the distance in feet, and then we can determine the time it takes in seconds and convert that to hours. So we're going to take the distance in kilometers, convert it to feet. Now once we have it in feet, we can use this conversion factor here. Let me highlight it. To convert it to time. So this 250 feet equals 1 second is how we're going to go from distance to time. So once we have the distance in feet, we can get the time in seconds. And once we have time in seconds, we can get the time in hours. So again, this is our link between distance and time. Is this 250 feet equals 1 second. So what do we need to know? We know how many kilometers in a mile. So the other conversion factor we're going to need is how many feet in a mile. So 1 mile is 5,280 feet. So again, what we're going to do is we're going to take the distance from San Antonio to Chicago, which is in kilometers, convert it to feet using the conversion factors above. Once we get it in feet, we can use this conversion factor in the red box to convert it to time in seconds, and then we can convert to hours. So the other conversion factor we need is how many seconds in an hour. So 1 hour is 3,600 seconds. So now we have all the conversion factors we need. We can determine the time it takes in hours. Let's draw our train tracks. So we're going to start with kilometers. So 1997 kilometers. The first step, we want to convert kilometers to feet. So in the next empty train track, we look at our conversion of miles. Oops, I made a mistake. Let me go back. Sorry. We're going to go from kilometers to miles and then miles to feet. My bad. Because it's giving us how many kilometers in a mile. So we're going to convert kilometers into miles. So for our conversion factor with mile and kilometer, we're going to put kilometer on the bottom. And we're going to put mile on top. This is converting distance in kilometers to distance in miles. In the next empty train track, we want to convert miles into feet. So again, we know that 1 mile is 5,280 feet. So since we're starting with miles here in our next empty train track, miles goes on the bottom and feet go on top. So now we have our distance in feet. Next, we got to use this conversion factor here to convert feet into seconds. So since we're starting with feet here, in the next empty train track, feet goes on the bottom, second goes on top. And we need one more train track. Where we convert seconds into hours. Since second is here in our next empty train track, second goes on the bottom and hours go on top. So now you see everything cancels except hours. Now, if it didn't give us the speed of dash, then we couldn't solve this problem because we couldn't convert between distance and time. So now we're going to multiply everything on top, divide by everything on the bottom. So the calculator tells me it's going to take 7.2904377 hours. So let me just double check my work. So we're not finished. We got to look at significant figures. So if we look at our original numbers, 250, there's no decimal point, so this has 2 significant figures. 1997 has 4. 1 mile equals 1.609 kilometers. This is again English to metric, so we have to include it. So this has 4 significant figures. 1 mile is 5,280 feet. This is exact. And 1 hour, 3,600 seconds is exact. There's one typo. Let me go back and change that. Let me redo it, see if there's any change in the answer. I doubt there's that much of a change, but we can double check. Should have been 1.609. Little bit change. We get 7.2. So you get 7.281356 hours. A slightly little change in the answer. But now if we round to the correct number of significant figures, we'll see that we should round to 2 sig figs. So 1, 2. So after the 2 is an 8, so we should round up to 3. So even when I had the other number, we would have still rounded to 2 sig figs, and we would have got the same result. So the answer is 7.3 hours. So moving on to a different type of problem. Here we have a sheet of aluminum foil, has a total area of 2.50 feet squared and a mass of 5.7005 grams. What is the thickness of the foil in millimeters? And it gives us the density of aluminum is 2.699 grams per centimeter cubed. So what we have to remember, and it gives us an equation, it says volume is equal to the surface area times the thickness. So that's what this equation is saying here. It's saying, okay, if we have to find the volume, it's given you give the surface area times the thickness, you can find the volume. But what we're looking here for is the thickness in milliliters. So we're looking for thickness and what we're given is the density, the surface area, and the mass. So if we rearrange this equation, we'll see to solve for the thickness, we need to have the volume divided by the surface area. So if we know the volume of the foil and we know its thickness, we can find the surface, if we know its surface area, we can find the thickness. And again, there's many different ways you can approach this. So one route is if we start, so we need the volume and we need the surface area. Well, the surface area, it's already given to us, is 2.50 feet squared. So that's given to us in the problem. But the volume, we don't know. It's not given to us in the problem. So we have to use the other information to determine the volume of the foil. And the other information given to us is the density and the mass. And the density is in grams per centimeter cubed, and the mass is in grams. So if we know what the equation for density is, it's density equals mass over volume. And so if we want to solve for volume, volume equals mass divided by density. So if we know the mass and we know the density, we can calculate the volume. So now, we just kind of set up a route we're going to take. We're going to start with the mass in grams. From that, we can find, using the density, we can find the volume in centimeters cubed. Now we have to use the volume and the surface area to find the thickness. However, there's going to be a little bit of a side route we have to take. So before that, we have to convert the thickness into centimeters squared. Remember, or excuse me, the surface area is in feet squared, we're going to need to convert it into squared centimeters. So once we have the volume in centimeters cubed and the area in centimeters squared, then we can calculate the thickness. So you got to do these two things independently. So again, we need to find volume and surface area in order to find thickness. To find volume, we use the mass and density, and that gives us centimeters cubed. Now the surface area has to be in the same unit as the volume. And since volume is in centimeters cubed, surface area has to be in centimeters squared. So we're going to take our surface area, convert it from feet squared to inch squared to centimeters squared. And once we do this, we can get this, the thickness in centimeters. Once we have the thickness in centimeters, then we can convert it to the thickness in millimeters. So we're going to do like two separate calculations, and then we're going to combine them at the end to get the overall value. So again, we're going to take mass and density to find volume in centimeters cubed. Then we're going to take the surface area, convert it into centimeters squared, because both the volume and the surface area have to have the same base unit. They have to have centimeters. And the reason we're doing this is because thickness is equal to the volume divided by the surface area. Once we do that, we get the thickness in centimeters, and then we can convert it into millimeters. So we need a few equations, conversion factors actually. So we need to know how many inches in a foot and how many centimeters in an inch. Yes. And also we need to know how many millimeters are in a centimeter. And this is a very easy one to remember. If you remember looking at a ruler, between the centimeters, there's actually 10 dashes. So that tells you that there are 10 millimeters in 1 centimeter. So now we're going to convert feet squared to inch squared. So we need to square feet to inches and inches to centimeters. So 1 foot squared, 144 inches squared, and 1 inch squared, 6.16. Now it looks a little messy, but let me just recap what we're going to do. So we're looking for thickness in millimeters. We were given an equation with volume and how volume is equal to the surface area times the thickness. So we rearranged that to show that volume divided by surface area gives us thickness. So in order to find the thickness, we need to find the volume of the foil and its surface area. So to find the volume, we're going to use the density and mass to give us volume in centimeters cubed. Since volume is in centimeters cubed, we need to take the surface area and convert it into the same base unit squared as volume is. So since volume is centimeter cubed, we're going to put surface area in centimeters squared. Then we can find the thickness in centimeters and then convert it to millimeters. And so the way you can interpret the density, if you write it as a conversion factor, is that 2.699 grams equals 1 centimeter cubed. So now we set this up. We're going to start with the mass, and we're going to convert it to volume. So the mass is 5.6. So since we're starting with grams, in our next train track, grams goes on the bottom, and centimeter cubed goes on top. So you see grams cancel, and we're left with centimeters cubed. Now again, when you get this answer, make sure you keep quite a few significant figures. Okay. So that's the volume. Now we need to convert the surface area from feet squared to centimeters squared. And again, we're doing that so that the same base unit for both the cubed and squared terms. So we're starting with the surface area 2.50 feet squared. Now, since we're starting with feet squared, in our first empty train track, we're going to convert feet squared to inches squared. So feet squared goes on the bottom, and inches squared goes on top. The next one, we're going to go from inches squared to centimeters squared. Now we're going to get the surface area in centimeters squared. So multiply what's on top, divide by what's on the bottom. So now thickness. So we get 9.09228 10 to the negative 4 centimeters. Then we got to convert that to millimeters. Now we get 9.0990228 10 to the negative 3 millimeters. We've got to round it to 3 significant figures. So we get 9.09 10 to the negative 3 millimeters. And that's the thickness of the foil. So make sure you put things correctly, because as you see, even I can make mistakes. So make sure you get everything in the right numbers. And so that's the thickness of the foil, because if you can imagine a piece of aluminum foil, the thickness is very small. So this makes sense that it's about 0.01 millimeters thick as well.